Let's have a word of prayer and we'll begin. Father, in Jesus' name, we thank you, Lord, for all that you do. Ask your blessing this morning on our conversation, on the material we're going to cover, and pray that you would just help this material to become useful, to help us to understand it, learn it, remember it, and be able to recall it when we need to. We thank you and praise you in Jesus' name for all that you do. Amen.
Amen.
All right. We're going to talk about some mutations and what happens with them, and is there evidence for them, and some other things. So any questions about anything we've covered up to this point in prior sessions? This being session 5, you can tell because down here it says session 5. So I assume everybody has a copy of today's outline, yes? All right, so let's go ahead and begin the begin. Do mutations lead to evolution? And that's the question. So the analysis we looked at last week, this says the above analysis, but you know what we're talking about, provides little hope that evolution is even possible. The only human means of introducing genuinely new genetic material into the gene pool is by mutation. That is, a change in the DNA structure. So the significance of that is, what is DNA besides deoxyribonucleic acid? Is that what you were going to say?
Yep.
Okay. So now tell us what DNA really is.
DNA is what makes you you, but it's a certain combination of thymine, something, and something.
Yeah, 4 different acids, right?
Yeah.
Amino acids that form together in chains at the molecular level. We can't even get down to the molecular level with computers. Now let me give you a brief illustration. I started writing a novel once. It got to chapter 5, then I started seminary, so it's been sitting there ever since. That was in 1991, so it's really old and out of date. However, I had come up with an idea, which I still haven't heard anybody really deal with. I call it the IVLG, Infinitely Variable Logic Gate. In your brain, you have synapses. That's little gaps between nerve endings that communicates information. And the more often this particular path is crossed with information, electrical signals, the more reinforced that path becomes. That's how memories in the brain are formed and stored. Experiences are recorded, and so on and so forth. So that's the mechanical side of it, and that happens at the subcellular molecular level. Now, when DNA is in the picture, we can make really powerful computers. We have the ability now to get down and use silicon in small pieces and etch amazingly tiny circuits. In an inch by inch at one time, they finally achieved what they called the 1 billion megaflop. Anybody know what a megaflop is? Come on, really? You knew what deoxyribonucleic acid was. A megaflop is how many times it takes for a transaction to turn over on a grand scale, the total throughput of the chip, the computer chip. So 1 billion megaflops is absolutely enormous. Now, there was in 1984 an article in Byte magazine, spelled B-Y-T-E, as in bytes and bits computer stuff, right? Not somebody really hungry for a submarine sandwich. And in Byte magazine, this article talked about what they called, what did they call it? Basically biochips. I think that's the word they actually used, biochips. And they have discovered a way to actually grow long protein molecules in the lab and grow them specifically in exact precise shapes. So the thinking is, if you can grow them and have them connect end to end, you're literally growing molecules. And if you could combine those into an environment where information could be passed, the amount of power, electricity it would take would be minuscule compared to what these computers we have, PCs and stuff, would require. And the number of circuits per square inch would be at least 1 million, probably more like 1 billion more compact than the smallest we can do with the most fine etching we can do on a silicon chip to make the circuits. Is that making sense? So what we're saying is if we get down to the molecular level, we, in this little space here, we would have the power of a Cray supercomputer. Can you imagine that? You know what a Cray supercomputer is? You've heard of it? Okay, well, mainframes sit out there and they do all kinds of stuff. And they have found out a way to share data and so on and so forth, so that when this computer's not doing anything, it'll pick up the data and process it, and then when it kicks in, it kicks it back out, somebody else takes it up. And they can literally farm out processing to hundreds, if not thousands, of mainframe computers. And the amount of time it takes to do something is dramatically decreased because you got all these supercomputers working at it. The Cray supercomputer, and there are others that have come along as well, require supercooled internal, so that the circuitry passes information, and because it's supercooled, it doesn't heat up and melt everything. Okay, so we're talking an order of magnitude difference here. So the ability for man to mechanically introduce some sort of a variation would have to be done by plucking apart specific molecules in the chain and inserting specific other molecules with precise characteristics. This is something we have absolutely no ability to do. So we cannot even at this point, at the molecular level, introduce true DNA variations on a manual or mechanical level, okay? So that's kind of what we're talking about here. Hello, fellow bearded person.
Hi.
Oh, so we got 4 of us now?
Beards are cool.
Pretty soon we'll take over the world.
Grow it too.
Someday he can grow a beard, he can become normal. All right, so anyway, so there's little hope that evolution is possible left to its own devices. Now you remember the comment I made about if you took a bunch of highly bred dogs, put them on an island, after 2 to 3 generations you would have nothing but mutts and they would all look alike. Poodles would disappear, Chihuahuas would disappear, Great Danes would disappear, they would start to interbreed, and after 2 or 3 generations you'd have a bunch of dogs, a pack of dogs that just basically would devolve to a lowest common denominator, not evolve to more specialization. There is no record in the fossil layers that that has ever happened anywhere. Forms appear, the Bible refers to them after their own kind. They appear abruptly in the fossil record. There are no transitional forms. There have been some fabrications in an attempt to show people a transitional form, which have all been debunked, Piltdown Man, and so on and so forth. All right, so gene mutations occur when individual genes are damaged from exposure to heat, chemicals, or radiation. When mutation occurs, sections of the DNA are duplicated, inverted, lost, or moved to another place in the DNA molecule. So that's basically how mutations occur. The question is, do they lead to evolution? So, fruit flies, Drosophila. You ever heard of those guys? You've heard of fruit flies, right? Anybody ever eaten a peach fresh off the tree? You got a fruit fly trying to eat some of it too? Mm-hmm. Yeah. You ever had peaches fresh off the tree, by the way, right?
Yeah.
Oh, my wife, it took us a long, we've been married 43 years, okay? And still counting. The end of November will be 44. But she loves peaches and apples and all these things. And she'd get these things, you know, bite into a peach and it'd snap off like an apple. I said, honey, that's green. She said, what do you mean? These are perfect. I love them. And then we moved out here, and I introduced her to tree-ripened peaches, and her eyes were opened, or more likely, her taste buds were opened. And once you do that, it's just a world of difference, right? Okay, so little tiny fleas, they're flies, they run around, these fruit flies. They've been observed in the laboratory for more than 90 years in the quest of information about evolution. That's because they live and breed and die so fast that you got constant stuff going on, right? Generations and generations. 3,000 consecutive generations. Now these things live for a very short amount of time. Like I think a housefly, the average expectation is about 24 hours. How'd you like it if you had 24 hours to get everything you wanted to do done? Not much time. In their world, they probably think that's eternity. All right. So they are exposed to radiation in order to accelerate the number of mutations. Unfortunately, no genetic improvements have ever been observed as a result of mutation. And what radiation does is pieces of atoms bombard and break down molecules. So they have to reform and try and do things. Most observed mutations are either harmful or fatal to the organism. No observed mutations appear to be producing new organisms, that is, new forms after their own kind still seems to be the rule, right? Does that make sense?
Yeah.
Okay. Any questions?
Well, it just, I mean, when they talk about like people that have been exposed to like nuclear radiation, I mean, none of the Japanese after, you know, bombings came out to be superheroes or anything like that. I mean, they all either
What?
died or were sick or...
You mean X-Men's not real?
Well, it's just
Oh.
kind of like, I never understood how you can keep using the same idea and trying to, even though you've seen it, it doesn't work.
What is the definition of insanity? Anybody know?
Yes.
Or a definition?
Continuing to do the same thing over and over.
And expecting a different result.
Yeah.
If you keep tying your shoes before you put them on, it's still going to be hard to put them on. It's better if you wait till you put them on, then tie them, right? But if you keep trying, you might stretch the leather eventually, but it just doesn't work. Keep trying the same thing over and over does not produce a different result. So don't expect it to. Don't expect you kids, oh, Mom, please, can I go do this or that, right? Same old, it ain't going to work. All right, so anyway, that has nothing to do with genetic variation, but anyway.
Okay.
All right. So, no observed mutations appear to be producing new organisms or new kinds. Good morning. Grab one of those.
I'm sorry.
Unless there's a seat. There's seats back there. There's one at each seat. Yeah, this is for if we have more. More is better. Somebody said that was a commercial. All right. Here's the conclusion. Mutations are not a promising mechanism to provide beneficial changes in organisms. Now, that's a pretty profound statement. Anybody want to probe that a little bit, discuss it, ask a question, make an assertion to the contrary or whatever?
Is it a scientist that made that?
Well, that's our conclusion. These guys are scientists. There's a lot of scientists that say that. There are a lot of scientists that say, oh, we have evolution, but they can't produce the transitional forms. This is saying don't happen. They don't occur. So there are scientists on both sides of the argument, and they're still scientists. There are scientists on both sides of the climate change argument. It used to be global warming, but they had to change the name because things started getting colder every year. And then they had to change the name some more because they found out some people were actually tricking the algorithms they were using to do this stuff and had a couple of other things off so it looked worse than it really was. By right now, New York City was supposed to be underwater. Hello?
The UN just came out with a report they were talking about in the news that basically we're all going to die like in the next 20 years.
Yeah.
They're all going to...
Yeah.
I think I saw that.
Yeah,
Yeah.
It was horrible. I mean, it's like for what they were saying, we're supposed to be, heat up and burn up and die, you know, in the next 20 years. If we don't cut everything in like over half. It's over half of all the carbon emissions that we produce. And I'm just like, okay, how you gonna do that? How you gonna do that and not go back to the Stone Ages? You know, I mean.
Well, how many cycles of ice ages and then the other extreme have we had in the Earth's history? We can record quite a few in the fossil record. We see evidence of it. I told you about the flash-frozen mastodon up in within the Arctic Circle in Siberia with tropical plants flash-frozen with him. Not fossilized at first, but flash-frozen. I mean, he died, but he was frozen. What happened? A climactic, that's a bad word. A cataclysmic climate change took place. And what happens when you have a huge explosion, let's say, of the Yellowstone caldera. You've heard about that, right? We live right next door.
Oh, yeah, that.
Super volcano?
It's a
Yeah,
super volcano.
it's supposed to be like in
You have a
20
whole
that was
ring
in
of
2012,
volcanoes.
The whole Earth, yeah.
Well, that was the calendar thing, you
Yeah.
know.
It's a good movie.
But you've got a hot spot. Well, this is science, though. Yeah, there's actually a hot spot, an enormous sort of a dome of magma that's very hot, and the crust, the tectonic plate, very slowly floats over it. So we can look where it's been, and we see old extinct volcanic activity in mountains that have been produced, and there's tons of activity right now in a place called Yellowstone National Park, right? So you see these things bubbling up because they have all this energy underneath producing all this heat, and the result is what we see taking place there. There's been a lot of people out there studying what's going on. So as the plate moves across this huge dome, then new activity takes place. Now it's slow, it's not something we can see. You can't put a camera out there and go snip every hour and see it. It's not moving that fast. But it's moving fast enough that we can see in the geological record these things have taken place, and events have occurred that show that there used to be volcanic activity that has floated over, but there's still stuff going on here. And they're saying 600,000 years ago, so it's about time we had another one. It just depends on how you look at it, but either way, if that happens, what's going to take place is you've got the winds going over with the jet stream and other things. It will dump, this would be, I think, I don't remember the numbers, I'll probably say it wrong, a gazillion times worse. See, that's a made-up number, so I can't be wrong now. A lot worse than Mount St. Helens ever thought of being. Mount St. Helens is a burp compared to what would happen if the Yellowstone caldera blows, right? And what will happen, I mean, Krakatoa, remember Krakatoa? I mean, you may not remember it, but you've heard it, everybody ever heard of Krakatoa? It's an island in the middle of the Pacific, blew up, and there was this, and they heard it like thousands of miles away, this enormous noise. But that still is a pinprick compared to what would happen if this caldera blew. And it would just gush all kinds of ash and stuff into the atmosphere, and it would block out the sun and literally create a freeze. And we refer to it as a nuclear winter. The fear of using nuclear weapons on a global scale is that it would produce such a cover and it would cause a world global freeze because the radiation of the sun would not penetrate and get to the earth, and a whole bunch of other bad things would happen too. Then we'd be crawling around being the walking bad guys. All right, so we see things happening. There are scientists on both sides of that issue. There are scientists, real scientists with real science on both sides of the evolution issue, and that's my point. There is real science that works on both sides of the issue. The evolutionary school has never been able to satisfactorily answer many of these questions, especially things like the gap in the fossil record and so on and so forth. Okay? All right. Now, some very smart guys have made very erudite defenses of their position, and they can stand up there and use a lot of big words and very fast continuity in their sentences and sound very smart, like they know what they're talking about. And they do. They know what they're talking about. They know how to use the words in correct syntax and so on. But sometimes what they say isn't necessarily something that deals with all of the observed reality. Part of science, and when I did the apologetics, which is the precursor to this is sort of like the next step. So we're sort of taking more time on the evolution and creation piece. But in apologetics, there are different ways to understand truth and to examine truth and see whether this is really real. And when we talked about empiricism, anybody know what empiricism is? Anybody know what empirical evidence is? Anybody know what the scientific method requires? Okay,
You need a question, you need research, you need hypothesis, you need, yeah, you need to conduct your experiment, then you need to conclude, and then
so what happens when you conclude?
you have to sum up exactly.
But you have a, what's next after hypothesis?
Yes.
Say theory.
Oh, yes. Theory.
Theory.
It's right there.
Yeah. Okay, very good. You caught him red-handed. Hold up your hand. No, that's not red. Okay, well anyway. So the point is, you only get to a theory once you work on your hypotheses and come up with one that seems to survive all of your attempts to dissuade it or disprove it or whatever. At that point, you then form a theory. But along the way, the scientific method requires evidence. And the problem with the scientific method is that it requires evidence based on the five senses, what can be touched, what can be tasted, what can be smelled, you know that. The five senses are required to develop empirical evidence satisfactory for the scientific method. So you'd think that would be enough, and it should be, but it has limitations. We find that there are things that happen that none of the five senses, and even the most sensitive measurements, can explain. So we can observe, we can record, but we can't explain it. So the next thing we come up with is people developing mathematical models and other kinds of constructs to explain why this happens the way it does. So why is it we have all these things happening, but we don't see anything in the fossil record showing a transitional form to a new kind? I mean, we can breed dogs all day long, we can breed cats all day long, but we cannot find a transitional form between dogs and cats, or between whatever supposedly preceded them and whatever supposedly would follow them. Right? So observable evidence becomes the gold standard, but it also becomes the limitation. We can't see or reproduce evolution in the lab. Can't get there from here. It'd be cool if we could, but we have yet to succeed in doing anything that comes even close to an actual evolutionary step in the lab. Does that make sense? If you want to say something, please go ahead. This guy's smiling like a Cheshire cat back here. I just have a... No, not him. He's not. He's smiling too. But anyway, I'm not calling attention to anybody, but I want you to know. Feel free to ask questions. I'm not afraid to deal with questions.
So, I mean, I guess you could say with evolution, it's still a theory. I mean, because you can only, when you do that, you're only testing one small thing at that time, and then trying to prove that either what you said or that it's wrong. You can't, I mean, when you talk about evolution, it's such a vast, thing that it's like you can't prove it all in just one experiment. So, I mean, technically it's still just a theory, but they push it out like fact, like yes it is, and then they try to cover up all of the inconsistencies.
Right. Exactly. So the problem with, when we talk about evolution, the evolutionary construct is still a theory. It is treated like a law. And anyone who tries to go into the educational system and even suggest there is anything else besides evolution gets lambasted and shamed and pushed out, and professors in universities who have long tenure get fired abruptly because they introduce this. It's a real thing, folks. It's a real thing. And tenure, professors with tenure supposedly can't get fired, but you find a professor that talks about intelligent design or asks about it and suggests it might fill in some of the gaps we have in the evolutionary theory, get run out of town on a rail. Literally, hundreds of instances of this have happened in the last 15, 20, 30 years. So it's not new, and it's actually getting worse. So you don't dare bring, now the way they refute it is the emotional response based on the attachment to the idea. How dare you say that evolution is not real? Well, how dare you say it is when you don't really have enough evidence to say it's not a theory anymore, it's a law. What it takes to move a theory to a law in the scientific method is it is observable and reproducible evidence. And right now we cannot observe or reproduce anything that would suggest that evolution is more than a theory.
Because so many scientific laws, I mean, like, on the books, this is this. I mean, like, I would think maybe like the law of gravity. There is gravity. They've
Yeah.
shown that there's gravity. But, I mean, there can't be that many
I
out
mean,
there.
Isaac Newton got hit on the head with an apple. Boom, there's gravity.
Yeah.
I don't know why it took that to figure that out, but anyway, it did.
But I'm just saying, I mean, in the books, what, there's maybe 100, maybe?
I don't know, you got the
I
laws
don't
of
know.
thermodynamics, and you've got laws of quantum physics, and you got different mathematical laws whereby you can model events and things and explain quasars and pulsars out there. You know, so there are a lot of scientific laws that have passed the test of being a theory. I mean, 2 plus 2 is always going to be 4. So there are mathematical laws. Now we have to deal with imaginary numbers, and I hate to warp your minds too much. The young guys, you may have run across them already. You know what an imaginary number is? Yep.
Yep,
Oh, really?
yeah.
Okay, let's hear it. What's an imaginary number?
An imaginary number is a number that, I have to rack my brain because that was a long video. The imaginary number is a number that we don't see as a number, but is actually there. But it,
It's interesting. No, it's interesting.
What's the square root of -1?
that's
What's the square root of 1?
positive.
Everybody say 1.
Yeah, positive 1.
But you cannot have a square of any two numbers, any number squared will never produce a negative number.
Or is I? I was drawing an I.
An I,
Yeah.
yeah, which represents the imaginary number, right? So the square root of -1 could be an example of an imaginary number, right? Because it mathematically is not possible. But we have to account for that. If somebody can think of doing it, how do you do it? What does it produce? So we have this expanded universe of numeric and mathematical laws, and scientists use mathematical models to try and model what they observe in nature and explain how it works and what we can expect to happen next. And that's basically how black holes were postulated, because of observed phenomena that didn't seem to fit the normal laws of interaction between time, space, and matter. Right? But when Einstein came along, when he came along and he postulated E equals mc squared, that opened up a whole new universe of thought and speculation. And then people started talking about the space-time continuum and how it can be bent and change shapes, and time can speed up or slow down relative to matter and physical changes, and what happens when gravity becomes so concentrated that even light can't escape it. By the way, we mentioned that light has mass, right? What do we call it? What do we call particles of light? Photons. And we can actually measure the impact of a photon and thereby derive the mass of a photon. Mass is not necessarily the same as weight. And see, we in scientific terms and mathematical terms, we have to distinguish between the concept of mass, which has inertial issues and so on and so forth, versus the concept of weight. Something that has mass does not necessarily weigh anything, in other words. But light can actually produce a response. It can hit certain materials and boom, we can generate electricity because of that. Now we don't, we found that out before, then the scientists went to work to try and explain how does that work, right? So that's what the scientific method does. It works with the reality as it observed and then tries to derive a conclusion as to why it works the way it works. Is this making sense?
Mm-hmm.
Okay. So, now, did I wait too long? Yeah, okay. So, unfortunately, no genetic improvements have ever been observed as a result of mutation. That's B1. Typically, I'm reading the footnote down here at the bottom. I know you can read too, but let's just kind of discuss it. Evolutionists point to people with sickle cell anemia who appear to be resistant to malaria as an example of a beneficial mutation. However, though sickle cell anemia may help people resist malaria if and when exposed to it, the disadvantage of being anemic all their lives seems to outweigh the advantage. Another typical example, in quotes, of supposedly beneficial mutations are bacteria or insects which appear to become resistant to antibiotics or insecticides. That was a problem with Medfly. We talked about antibiotics and superbugs that become resistant and so on and so forth. My mom died of one of those, a combination of that and a couple other things. But she developed an infection, she had a stroke and started to go into renal failure, and there was an infection she had, and the most potent antibiotics came up with wouldn't touch it. And that perfect storm killed her within 5 days. A little CNA, you know what CNA is? Nursing assistant.
Yeah.
Something nursing assistant. Anyway, she was in there on Saturday. How you feeling today? And, well, I don't know. I've got some pain and stuff, and I'm having some problems on my left side. Oh, well, some days are better than others and whatnot. Didn't say a word to anybody. And then Monday when the doctor came in, they slapped her in the hospital. She was having a stroke. So anyway, stuff goes on, but this resistant bacteria would not respond to any of the antibiotics they pumped into her system. So the bacteria and insects that died were not resistant, allowing a proliferation of bacteria and insects that were. In cases such as these, no new organism came into being, and through the demise of the non-resistant strains of bacteria or insects, some biodiversity was actually lost because one form died off and the other form stuck around. Finally, some evolutionists will point to the peppered moth, the Biston betularia. That's one that had spots, okay? In England, as an example of an advantageous adaptation. When the bark on trees was white, white-peppered moths were the dominant color. When industrial pollution, like smokestacks back in the day when we used a lot of coal, turned the bark black, black-peppered moths became dominant. Once industries cleaned up their population, the bark once again turned white, as did the moths. Creationists would point out black moths were always present in the population. No change that occurred was permanent, and no new species was ever formed or in the process of being formed. There is nothing here that supports evolution. Now, you sort of briefly mentioned whatever happened in Japan. Nobody grew an extra head. Nobody became a super, X-Man person that could fly around or melt things with his eyes or whatever. That has never happened, and probably won't, even though I'm really sorely disappointed because I thought X-Men was real. But anyway, all right. Okay, so let's move on. Number of genes required for a new structure. In an organism as simple as the fruit fly, perhaps 30 to 40 different genes are required to encode all the information necessary for the structure of its wings. Biochemists conclude that even the simplest new structure probably requires at least 5 genes of encoded information. Now remember, only 1 gene in 1,000 is either neutral or beneficial. The odds of 2 genes producing a neutral or beneficial change by mutation are 1 to 1,000 times 1 to 1,000, or 1 to 1 million. Now we're not talking 1 in a million. We're talking 1 to the millionth power. In other words, you put a whole bunch of zeros after the 1. Okay, so the odds of 3 genes producing neutral or beneficial change by mutation are 1 to a billion. 5 neutral, beneficial, and mutational changes will occur in genes once in 10 to the 15th. That's 15 zeros. This sort of thing had to occur in much more complex structures throughout all species of organisms during the entire evolutionary history. Yes.
So, I apologize, I do not understand this part, like what you're saying, neutral or beneficial. Is this like in the DNA?
If there was
strand?
a new gene that was either neutral, produced no benefit or problem, or a beneficial gene, the odds of getting one of those are 1 in 10 to the 15th power to get enough of them to actually cause a new structure like a wing on a fly to form and become part of its genetic structure that was reproducible when they reproduced into new ones.
So, and that's just a simple, so
A
like if
simple-
something for like us would even be,
A simple structure takes at least 5 genes, and there's a bunch of little molecules in that gene, and they have to be very specific to do very specific things, and to become positive, the chances of that happening are absolutely minuscule. So does that help?
no, it does, yeah.
Okay. Anybody else?
Yeah.
Yes, sir.
One way I like to think about it too is all of the letters that are on this paper are arranged in a specific instance to form the words and everything that we see here. If you were to take all of these up and just put them in a shaker and throw them, how many times is it going to take you to get this
This exact
exact same
combination.
combination
Oh
again?
my goodness, it would be
You never.
forever.
Right?
1 in 10 to the 15th.
Yeah, I mean, it would take you-
Or more.
Yeah.
And of course, they talk about the monkey that randomly types and eventually would produce all the sonnets of Shakespeare, let's say.
The library that exploded.
The what?
See the library that exploded.
Oh yeah, explodes and it comes back together in the exact same form with all the words.
Oh yeah, because that's kind of like how they say like in Planet of the Apes. That's how come he was smart, so that he was able to make all the rest of the apes smart, and so, yeah.
How did he do that? Oh, maybe it was what's that guy? Right?
Spock?
Yeah.
Doing Vulcan.
Doing the mind meld,
Yeah,
to
mind
sort of
meld.
swap brains or whatever for a minute, make them what?
Who's that? I'm not catching on.
Who's
Oh, and Planet of the Apes, at least in the newer version, they were basically saying like Caesar, because the guy was trying to make a thing to stop Alzheimer's.
Right, I
in
see
the movie.
now.
Yeah, okay. And so he
No,
gave him the stuff, it started to make the ape smart, and then as the movies go along, he's actually teaching the other apes
Right.
how to talk. You know, at first they can't really speak, but they're doing sign language and everything like that. He's the only one. There's a few of them that could kind of speak, but supposedly as he's teaching them and the other ones teach the other ones, they all start to be able to speak, and then you get to the point where they take over.
Oh,
We
yeah,
become
okay.
stupid, and you know can't talk anymore, and they can talk.
And suddenly they
Yeah.
reproduce enormously and are everywhere.
Yeah,
How does that happen?
you know.
Quit it!
So yeah.
I didn't even do that.
Break your phone on your own time.
But then that would be like basically they develop something else in their brain that that's cool.
Right.
Yeah. Yeah, they develop something else in
She's
their
over there trying to
brain
figure out
that they didn't have before.
Right, right.
Yeah. Which I always
Right.
was kind of like, okay. I mean, it's fun in the movies.
Yeah. Well, there's a lot of movies out there that have fun with stuff, but you know, there's a lot of scientists out there that have fun with stuff too. So anyway.
Well, that's why it's science fiction.
Now, how about allopatric speciation? Does it lead to evolution? What are you frowning about? Everybody knows what that means, right?
No, I didn't know.
Well, she's back there looking horrified. I would spit so much out, I'm wondering if I'm cursing. Okay, see, okay, stop. Everybody go like this.
Wait.
Now go like this.
I think I could do that.
Now do that back and forth.
What?
Oh, I can do that.
No, I didn't close it and open it, not like that. I mean, without moving the outside
Wait,
finger.
wait.
Okay.
Oh, that's so cool.
No, but can't do that.
I can do that.
Slowly.
There, get it out of your system, okay? These guys have been over here going, ooh, it's showing each other how to do that. So, well, okay, let's complicate it a little bit. Let's make it a handheld Rubik's Cube. All right. So, allopatric speciation may be defined as new species forming due to the separation of one species into two populations of geographically and thus genetically isolated organisms. So let's say, well, I don't know, I don't remember, oh, fruit fly is off the coast and onto an island, miles from land. The fruit flies on the island will go on to develop their own generic gene pool, which would become slightly different than the generic gene pool of the continental fruit flies. I was going to say monkeys on an island, different islands and adapt differently. But anyway, so as time passed, the gene pools would be so different that if the two species were placed back together again, they would no longer be able to interbreed. Now, we sort of briefly touched on this when we talked about what happens when you interbreed species. And what happens when you interbreed a horse with a mule, you end up with a donkey. Right?
Oh, you're not allowed to say that? I'm sorry. I thought
Sure
that,
you are.
It's in the Bible. So.
It's in the Bible.
Yeah.
Different translations.
Potty mouth.
But that's okay. Of course, you know, I had a pastor point out to me who was from Minnesota that Green Bay is in the Bible. And I said, what? And he's pointed me some passage over here in the King James Version. I think it was in Psalms. And something about being by the Green Bay tree.
Heck
Green
yeah.
Bay's in the Bible. Okay, so the Broncos aren't, but the Broncos beat the Green Bay Packers in the Super Bowl.
Whoa, whoa, whoa.
Whoa, whoa, whoa,
Summer
whoa.
Bowl.
They did.
Summer Bowl. Summer Bowl.
Okay. Gee, did we just put that on? Never mind. Okay, so you get the idea with allotropic species, separated populations producing and become so far disparate that they cannot any longer interbreed.
Well, wouldn't it be like within like different kinds of cats? Like they're saying a lion would be a cat and a tiger would be a cat, but like you said, when they did,
A liger.
yeah, the liger, that they can't produce anymore.
Yeah. But in real, I mean, how do you get ligers? How did they get ligers?
Well, lion and tiger.
How did they do it though?
I don't know.
Did they actually
They
mate?
Did they
Did
really
actually
date
mate
and
the
form
lion?
a
Oh, I don't
relationship?
know. No, it was probably
Artificial insemination.
right.
That's how they do that sort of stuff. I mean, they kill each other before they mate, right?
So they put each other together?
Don't even try to think
Yes.
about it, buddy.
Okay.
No, it's
We'll talk to you about it later. A whole other conversation.
Yeah, that's a whole other conversation.
All right, so anyway,
It's another class, boy.
another, and I'm not teaching that, thanks to that. All right, you'll find out. All right, so, allopatric speciation then, does it produce evolution? Now, creationists point out that while new species may indeed be formed in the above manner, what has happened is that the smaller isolated group lost some of the possible combinations present in the larger original gene pool. When organisms lose the capacity for certain variations, they may eventually not be able to interbreed with the original species. So, and these are creation scientists. They're actual scientists that are real scientists that are also creationists. Okay? Real science supports this. So, a geographically isolated group eventually settle down to whatever its most generic gene traits are, like the dogs on the island. Evolution, moving from simpler to more complex organisms, requires vast amounts of new, additional genetic information. Thus, allotropic speciation, while producing new, more genetically restricted species, is not the first step towards evolution. See, the evolutionists want you to believe that as things happen and they adapt, they become better at it and smarter and improved and more complex and able to deal with stuff. And so eventually we see these things taking place on a more advanced level. That's how evolution is supposed to take place. Left to its own resources, we don't see that.
So basically, we're lazy.
Yeah, okay.
Well, I mean, you're saying it goes to the simplest form, so basically, we don't want the genetic thing doesn't want to change and become crazier and more, you know.
I'm not sure the genetic thing wants anything. I mean, if it's happening below our conscious ability to affect it. So, but I get what you're saying. Evolution, you know, when we leave things to their own courses, will devolve, not evolve. And that's what we see, time and time again. And the reason fruit flies are helpful is because they have, you know, in 24 hours, or excuse me, in a year, you've got a 24-hour generation. So how many of those are in a, you know, you got 365 generations. Actually, there's more than that, but that's just a quick example. So each time a new generation is introduced, that's going to accelerate the number of changes that could or should or might be realized in a different situation, where fruit flies are out here and they don't have any fruits, they just have what we would call vegetables to eat. So they're probably going to adapt and eat what's there, even though they like peaches.
And
Right?
bananas.
Huh?
Bananas.
And bananas.
Bananas are
But bananas and peaches grow in very different environments. So they still have to adapt, right? But they would adapt and survive. All right, so that doesn't produce a problem from the creationist point of view, nor does it prove that there's any real evolution that's taking place. It's sort of a, here's a fact, and this is what happens. We can observe the changes, but it does not lead to any kind of evolutionary change. It actually simplifies the isolated group genetically, instead of becoming more specialized and so on and so forth. All right. So is there evidence? Any questions about that? Hello, Patrick. Okay, so is there evidence for evolution on a biochemical level? This is kind of cool. I don't know if I included that here or not. If the organisms that appear only recently in the fossil record are the crowning efforts of evolution's 600 million year history, then we would expect those organisms to be the most developed and complex of all organisms. Moreover, since evolutionists contend that human beings are among the last of the organisms in the evolutionary sequence, we would expect that human beings are more complex than earlier, more primitive organisms. Right? If we're following evolutionary thinking, right? So how do we measure complexity, and what about counting chromosomes? We know that each species has a different number of chromosomes, unique to that group. How many do we have? I know, you see it on TV every night.
How many chromosomes?
But, what?
No,
23 something, and you can buy your genetic history and prove it for this, and this.
all that DNA
23.
testing.
Yeah, the DNA thing.
Oh, so that's amazing. Okay.
23 something, and
That
they,
makes
so
sense.
the name of it is 23.
Never heard of that.
Do you ever watch TV?
No.
Okay.
Well,
you
yeah,
probably
it's just
watch.
this new thing.
Who cares?
You got like Netflix and Hulu and all the other stuff.
Yeah.
Yeah, where you don't see commercials, and so these guys are advertising this stuff constantly.
Yeah.
They want you to spend money to find out, and so they show, well, all this time I thought I was this, and I found out I was that.
Yeah.
This guy who thought he was, what was it? He was, oh, he thought he was Scottish, and he had a kilt, and he knew how to do all the stuff that Scots did, and he took a test and found out he was German, so he got rid of his kilt, and he got his lederhosen and started learning German songs. Really? Anyway, that was the commercial. Who knows if that was a paid actor or not? Probably a paid actor. Now, comparing amino acid sequences, what does that do? Where do amino acid sequences become significant? DNA. Okay, I was waiting for Mr. DNA back here to answer. He's busy sniffing the table or something. I'm not sure what. He got his face down there and he's working with air currents to lift the paper. I don't know what he's doing. Anyway, so comparing amino acid sequences in various proteins across organisms. This is a way that sort of covers both bases. The idea here is to endeavor to trace evolutionary branches by means of similarities and divergences in amino acid sequences in various proteins across organisms, from organism to the next, right? So we want to see if those same sequences occur in various, many, or all organisms at the DNA level, the same amino acid sequences. Can we find specific sequence structures then that seem to all appear in every species that has 4 legs or 4 appendages, something like that? All right, now cytochrome C molecules in all organisms are about 100 amino acids long, a small protein. When 1,089 different organisms are examined, their cytochrome C molecules all had the same 3D shape. So what we utterly fail to find, though, is any kind of confirmation by biochemical similarity or divergence of the typically assumed evolutionary sequence: the jawless fish, the jawed fish, the amphibian, the reptile, the mammal, and in humans. It's not there. Can't find it. Anybody ever try to get a train or a taxi or somewhere and they say can't get there from here? It's kind of like that. Well, this costs more money for the research. So conclusion, when genes and chromosome frequencies are compared across organisms, it is clear that numbers do not indicate complexity. Are we more complex than an amoeba? Yeah. But is that complexity, does it hold up at the molecular level in the DNA sequences where there are strings and strings and strings of hundreds and thousands of amino acid combinations? No. They're just as complex for the amoeba. There may not be the same number as they are for humans. So a comparison of amino acid sequences across organisms reveals no pattern of similarity between organisms that are supposedly more closely related. Now, theoretically, what's our ancestor? Who's Uncle Bob? He was a monkey or a chimpanzee or something, right? Theoretically, that's what the theory says. Thus, the evolution idea remains a theory because they still can't produce direct evidence of what it contends. Now, going to the Galapagos Islands helped Darwin form a lot of theories, saw a lot of divergent species, but that still doesn't work. Birds is birds, you know, monkeys is monkeys, iguanas is iguanas, peoples is peoples, moths are moths, except when you watch the movie The Fly, another one that I'm sort of disappointed in. I believe that was true.
Why?
The Fly, it's a movie.
The guy turns into a fly.
He learns how to transport
Way before his time.
molecularly from this place to this place, and he gets in the thing, he turns it on to set himself, and right when he did, this fly flew in there and landed on him, and when he got to the other end, the DNA between him and the fly were combined, and pretty soon he morphs into this creature, and that's the movie.
Yeah, Vincent Price did the first one, then Jeff Goldblum, they did redo.
A redo.
Yeah.
Have you noticed that Hollywood is getting less and less creative? They keep relying on everything and redoing it. So now these new movies star special effects and computer animations and stuff
Good point.
instead of actual people and actual real news stories. You ever noticed that? I've noticed that.
Yes.
And then they sit there, what is it, over about a 2 or 3 month period, one event after another, after another, after another, taking turns clapping each other on the back and saying how wonderful we are. Mutual Admiration Society. You ever notice that? Look how wonderful we are. We animated or we made another Marvel comic book into a movie. We redid another movie that was done probably better, but we did it again because we have more special effects or whatever, right?
Yeah, no, that's.
That's the best they can
exactly what they're
do.
doing.
I'd say Hollywood's devolving. I'd say that's an example of what we're talking about here. Okay, I'm sorry, I got off on a tangent there. Any, yes,
I just have a question about when you were talking about like with the fruit flies and like if, like they separate and they keep, you know,
the
reproducing, and then
allotropic,
they
whether
come back,
geographically,
yeah. So,
okay?
like, could that explain why, like, when, like, humans reproduce, like, sometimes there are, like, problems, like, there's, like, what's the word? When, like, people are born with, like, certain things, like, mental
Okay,
disorders
defects
or
of
something
some
like
kind,
that, like,
yeah.
could that be, or is that wholly not?
Yeah, maybe, maybe not. Now, I will say this, and this actually is a direct example of devolution as opposed to evolution. We knew a guy when I was in the Army at Fort Benning, Georgia, and he was sort of a drummer. I mean, I played in Army bands. I was a musician for 20 years, right? And we nicknamed him Lightning because he was really slow, not very bright. And, you know, he found out he could get credit, so he went to one store after another and got credit all about the same time, and he had a color TV, and he bought this, and he bought a whole bunch of stuff, and then all of a sudden he started owing for these store loans that he had, and he couldn't afford them. The monthly payments ate him alive. And he had a car that he ran till it wouldn't run anymore, and one of the guys in the band knew something about cars, and he took the engine, opened up, and pulled out the spark plugs, and instead of having a gap like that, this part that came around the bottom was so burned off, the gap was more like that. And so it wasn't, the electricity couldn't reach and make the gasoline explode, like in an internal. So it turns out his parents were first cousins. Now, when we find that intermarriage among humans in the same group produces less capable individuals, when you've got first cousins, and if it's closer than that, it's even worse, but first cousins produce a lot of problems in their offspring. He was a product of two first cousins, we found out. I really felt sorry for the guy. I have no idea how he's going to survive, but he's going to need a lot of help anyway. So, does that help answer the question? I mean, it's not defects directly or handicaps directly or something.
Well, so I
In
guess
a way, it
it's
kind of
like-
was, though.
It's kind of
right?
like backwards then, because you said that if the fruit flies, like if they separate and then they try and come back together, then it won't work, but it's more so like, I guess with humans, as you were saying, that like if you do it and they're already like close, is that, I don't know.
Well, if this group on the island is then reintroduced into the continental population,
Yeah.
they will have fewer, that's not a word. It is a word, but I mean, a less complete set of genetic options to interact with these, and so the offspring may not be as robust as they had been if they'd been left alone on the continent. I mean, we don't know that. I don't know if any specific studies have been done. There probably have been. I don't know of them, where an allotropic group, after several generations separated, were reintroduced to the population. What would happen? But I do know that one thing that, do you know how they got rid of bed flies in California? You know what the bed fly was?
The
Mediterranean fly, and it was ravaging crops and stuff, right? So they had to kill it. Remember how
They
they
checked
did
all
it?
the fruit and everything like that, but
Right.
they had to come in, but I don't remember. Maybe they had traps and stuff like that.
They sterilized all the male flies and then reintroduced them to the population, and eventually the sterile males would get together, and pretty soon they just started dying off because they couldn't reproduce in the numbers that they had before. So they purposely changed the genetic structure, if you will, of the male flies, and they couldn't reproduce successfully. So, you know, I mean, that could happen, I don't know. But does that, I don't know if that helps answer the question. Yes, sir.
So, I guess I have a question on like with people nowadays. I see more and more people with allergies. Like when I was a kid, I never hardly ever remember anyone allergic to peanuts, anyone allergic to dairy. You know, I mean, it's like most people. Once in a while, I heard about some people. Now it's like when they go to school, there could be half the class
have a peanut allergy. And even if they smell it, I mean, I know Pastor Ashley mentioned something to me that one kid is allergic to almost everything. He touched a cheese ball, and I guess he got a rash all over his skin. And so it's like, it seems like then people are getting more, or say less evolved, I guess, if that could be the case. I mean, we're developing all these problems, you know, in people.
And how much of that is genetic and how much of that is environmental and so on and so forth. So there's a lot, there are a lot of components to that sort of thing. I'd say you're right. Now, everybody used to go down to Arizona when they had allergies. They'd move down there to Tucson or Phoenix or someplace, right? And a lot of them start breathing the dry desert air and the heated air. I mean, you know, it gets like 110, 120 during the summer down there, right?
Yeah.
And all summer long. Once it hits 100 plus in April, it never goes back down basically until October, sometimes later than that. But I mean, can you imagine that from April, May, June, July, August, September, October? That's more than half the year, over 100 degrees. And it's very dry heat. So they go down there and sure enough their sinuses would dry up and all these allergies would stop giving them problems. But the problem was then they wanted to bring their gardens with them and their plants with them and stuff. And next thing you know, you got as much of that kind of stuff, you know, pollens and other kinds of things floating around in the valley around Phoenix that people are worse off than they were to start with. There is actually a thing called valley fever in Phoenix. And if you go and live there for a period of time, sooner or later, you will get valley fever. Now, it usually is only once, but it's not fun when you do. And that's what they call it. And the conclusion has been that it was the reintroduction of all these things that these people left to come out here and get healthy again. They brought them with them, so now that's not a place to go to get healthy. So
So, well, let's say people back like in the 1800s. I know people didn't live as long,
right,
and everything like that, but they seem to have less problems,
yeah.
less cancer, less this. I mean, everything. You know.
Well, we don't always know all the things that were there that contributed to death either, natural causes or otherwise, because they didn't necessarily know what they were looking at. I mean, you know, consumption. What's consumption? You know. But and the ladies used to, oh, I have the vapors, and then she'd pass out, you know, vapors. That's what they call it, you know. So well, consumption I think is tuberculosis, and it just kind of eats your lungs out. Yeah. And if you remember, Doc Holliday used to drink this opium stuff to kind of deal with the pain. He eventually died, but they didn't know what it was or how to treat it back then. But he died, and he died younger. So there's probably many of the same problems extant then as there are now. Not maybe all, probably more complex now. But that they didn't know what it was, so we can't look back and understand from the results of the autopsies or whatever, you know, what it was.
So maybe there was people with all these different problems
And we
back
didn't
then.
quite
and
understand.
Now we just understand more. That's why there's more.
Probably. I'd say there's probably a combination of both.
Okay.
Anybody else? Good question. I like good questions. I like better answers. Okay. Well, I suppose I should go ahead and close in prayer. What do you think?
Yeah.
Father, in Jesus' name, thank you for our time together. I ask that you would just guide and direct our steps through the week. I pray for the service this morning, that your Holy Spirit would just be all over this campus. As people drive into the parking lot, as they walk toward, they would have a sense of expectation. Children coming into children's church, parents going over there, and everybody else going over there to the main service, and as it takes place later. I pray that you would just be all over this campus. Touch hearts and minds. Speak to people and transform them into the image from one degree to the next of Jesus. We pray, Lord, that you would anoint our pastor and those on the worship team and those involved with other activities behind the scenes in a way that would just bring it all together and allow a transparent understanding and sense of your presence. Speak to our hearts, speak to our minds, and change us, we pray. In Jesus' name, amen.